Welcome to Lesson 3 of Unit 5. In this lesson, we will be adding fractions with like denominators using modeling. Here, we will be completing an addition calculation for fractions with like denominators. So our denominators have to be the same. So we're going to use our fraction circles and rectangles, pattern blocks, and fraction strips again to help us figure out the answer to an addition calculation involving fractions. A couple of different types of questions again. So given a visual, determine the answer to a given addition calculation. And then given the addition calculation, we will represent it by modeling in order to figure out the answer. Regardless of the type of question, please remember to check the final answer to make sure it's in simplest form. And if it's not, we will reduce to lowest terms, which is just another way you can say simplest form. Let's have a look at fraction circles or rectangles first. So in our first example, we've been asked to use the model to determine the sum. In our first rectangle, it's been divided into 7 equal sections, so our denominator is 7, and 3 have been shaded. Therefore, we have the fraction 3/7. In our second rectangle, which has been drawn the same size as the first, which it must be for us to be able to add here, it has been divided into 7 equal sections, and 2 have been shaded. So we see that our denominators are the same. They are like denominators. So now we got to use our pictures here to help us figure out the answer. So what is 3/7 plus 2/7? Well, if I take these two shaded portions, and if I put them in the hole on the left here, then that will give me 5 shaded sections out of the 7. So what we've just discovered is that 3/7 plus 2/7 equals 5/7. In our second example, we're given an addition calculation, and we're going to set up a model to help us figure out the sum. So if I look at the first fraction here, I see that my denominator is 10. So that means the whole that I choose, which in this case is going to be a circle, has to be divided into 10 equal sections, and I will shade 3 of them. There we have it, 3/10. My second circle, it too will be divided into 10 equal sections, and we will be shading 6. So this whole circle drawn the same size as the first, and we've shaded in 6 equal sections. We want to know the sum. Well, if I combine all the shaded pieces in one whole circle, I will get 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3/10 plus 6/10 gives us a sum of 9/10. In our third example, same idea, 3/8 plus 1/8. This time we're going to use a rectangle, divide it up into 8 equal sections, shade 3, there we go. For our second proper fraction here, divide it into 8 equal sections and shade 1. There we go. And we combine. So what if we could put all of the shaded pieces in one whole? Well, I'm going to pop this green one over into this rectangle, and in one whole I will get 4 out of the 8 shaded. Now we got to be smart, because for the first time here, this fraction is not in simplest form. 9/10 was, 5/7 was, but not 4/8. So we need to reduce this. So what's the largest natural number that divides nicely into 4 and 8? that would be 4. So 4 divided by 4 gives us 1. 8 divided by 4 gives us 2. So our final answer this time is a half. And this makes perfect sense with our model. If we look at this final rectangle here, we see that half of it has been shaded. So let's do the same type of questioning with pattern blocks. Here's our visual. Use the model to determine the sum. Well, we recall that each triangle represents 1/6. So I have 1, 2, 3 triangles here in this picture, so this would be 3/6. I have 1 triangle here in my second hexagon, so that would be 1/6. So I have 3/6 plus 1/6. If I combine all my triangles into one whole, into one hexagon, so I'm going to move this triangle, scoot it over here, and that would give me a hexagon with 4 triangles in it, which in turn is 4/6. So 3/6 plus 1/6 equals 4/6. However, 4/6 can reduce. It is not simplest form. I can divide numerator and denominator by 2, and that will give me a final answer of 2/3. Now we're going to use pattern blocks to actually calculate 1/3 plus 1/3. So the rhombus, remember, the rhombus is a third. So I'm going to draw my hexagon with 1 rhombus in it to represent 1/3. Add on another 1/3. And if I take this rhombus and pop it into this hexagon, so I put everything in one hexagon, one whole, that will give me 2/3. So 1/3 plus 1/3 equals 2/3, which is simplest form. Similarly, 2/6 plus 3/6. Every triangle is a 6. So 2 triangles gives me 2/6. 3 triangles gives me 3/6. Combine everything into one hexagon, into one whole, we get 5/6. So 2/6 plus 3/6 equals 5/6. And can 5/6 reduce? No, it cannot. That is simplest form. Please proceed to watch the next video in this lesson.